All right. So a couple things here. Again, we are doing three-dimensional shapes. Like I said yesterday, we're moving on from two-dimensional shapes onto three-dimensional shapes. We are still going to use a lot of those area formulas. Now, we're not going to talk a lot about area today. I'll reference it a few times, but if you have your sheets from the week before spring break, knowing some of those images that we found area for might help you as we go through and name some of these. So there's a lot of three-dimensional shapes that we're going to be dealing with, and there's different names for them. Now, you do have to know how to name it. There's not a section in the book on naming it because it's kind of assumed that you guys know this part, but I want to go through because there are some that are a little bit tricky. Most of these you probably have at least some idea of. Number one, all right, what shape is number one? The first one is a cone, all right? So on number one, before we look at any of these other things over here off the side, I just want to name these. So on your worksheet, I said name them off to the side here. The first one is a cone, all right? Now, before I go through all these with you, I want you to run down the list and see if you can give each one of these a name. It's okay if you're wrong. It's okay if you don't have a full name. But I want you to try to see if you can identify all the shapes on your own first before we go through them. Just give me a little bit of idea of what you remember. There are a couple that are similar types of figures. There are a few, like I said, that have similar names. There are also a few that you can call by different names. So, okay, I'm going to go first to the ones that looks like the majority of you guys remember. So the first one you guys have is cone. The fourth one, you guys are probably familiar with that one. Looks like a can of soup. It's a cylinder. Oh, what did I say? Oh, I'm sorry. Number 4, this one here, cylinder. All right, so now those two, it looked like most of you guys had. Going on down the list, all the way down at the bottom, that one was a cube. All right, now there are other names that we could use for a cube, and I'll hit on those here in a minute. And then the other one that a lot of you guys had, now there was a few people that got a couple names mixed up. The remaining 4 images here are all different types of either pyramids or prisms. Most of you guys did have number 5. What was number 5? Prism. No, number 5 was not a prism. It was our, if you think about ancient Egypt as our pyramid, right? It comes to a point. All right, so that's our pyramid. Which other shape is a pyramid up there? Three. Pentagon. All right, now I'm glad you said what that base looks like, because on these two we can get a little bit more specific. Since we have different bases on here, this one we said is a pentagon. What's the base on this one? Square. Square. So we could get more specific. This one, not only could we just call it a pyramid, but we could call it a square pyramid, and that's probably the one that you're most familiar with when it comes to pyramids. This one you said, what was the base again? Pentagon. All right, so on this one, so we don't just say pentagon pyramid. I don't really have a good reason why. Pentagonal pyramid. They like to add AL in a lot of these words when we do the pyramids and cylinders. Some of them, it's just the name, but I don't know. It's kind of goofy. All right, we have 3 and 6. Sorry, not 3. 2 and 6 are both what shapes? prisms. So 2 and 6. So it does look like a 10. All right. Both of those are prisms. Now, let's start with 6 because this one people get right more often. What type of prism is that? So we want to get a little bit more specific with our names. So look at this one. We got a hexagon on the top. So it is a hexagonal prism. Hexagonal prism. And then the top one there, number 2, what type of prism is that one? That's a tricky one. It is a triangle. All right. So this is an 8. Yeah, I'll talk about it here in a minute. Triangular. All right. Triangular prism. Now, how do we name these things? So a lot of it has to do with the base. All right. The cone, the sphere, sorry, not the sphere, the cylinder, I mean, the cone and the cylinder both have a circle for the base. There is no extra name that we're going to give those to because the base is always the same. The other ones on here are prisms and our pyramids. They do have different shapes that you can use, and they'll still be a prism. It's just changing the name because of the shape of the base. Number 2, the thing that makes this one challenging is these 2 triangles here. Those are our bases. All right, those are our bases. Like I said, when we did 2-dimensional shapes, our base doesn't have to be on the bottom. All right? And that happens a lot when we talk about our prisms. The base is not going to be on the bottom all the time. What you have to look for is you have to have 2 sides that are parallel to one another. So in parallel planes. So in the triangular prism, the 2 pyramids are in parallel planes. On the hexagonal prism down here, yeah, we have our 2 hexagons. Those are our bases. They're in parallel planes. Our pyramids, they only have 1 base. The base will always be across from the vertex, the point at the very top. As for the sides, the prisms always have what shape on the sides? What shape do we have around the sides of our 2 prisms? Rectangle. Rectangles, all right. And then our pyramids, we have what on their sides? Triangle. Triangles. So as we look through now and go on to our nets, these are nets. Whenever we talk about nets, they are going to be the shapes that are made if we were to take a 3-dimensional shape apart and lay it flat. So on here, there's our cone. And when we take our cone and we take it apart, it's actually just 2 shapes put together. It does kind of look like a bird, but we have a circle on the bottom, and then the top part. What is that top shape? Part of the circle. So it's a little less than a semicircle, and it could be even less. It could be more, depending on the size and shape of the cone. But there's a name for that, and we had that name back in our last chapter when we were dealing with area. Anybody remember? Anybody take out that sheet of area formulas that you have? We found the area of it. We have 2 radii, part of the circle. Not going on, so somebody tell me. So part of a circle. A lot of times it'll look more like a slice of pizza. A sector. All right. This one is almost a complete semicircle, but it will always be some type of sector. If you look at the one up here, A on this first one. That work? No. Thank you. All right, so on that first one, A is our correct shape. Now, the rest of these, again, you have your nets go through real quick, see if you can identify which net you think each one is. All right. Again, make sure you're looking for the shapes that are in the original figure. So all the shapes that make up the sides are the shapes that you should see in your net. So take a minute. We're going to go through those quickly. But each one of those shapes, I do have all of them here. Shapes that are there, so you can identify certain ones. Now, when we get into our next section, it's important to be able to identify what the net is because we're going to be looking at something called surface area in the next section. When we talk about surface area, there are multiple ways to find it. There are going to be formulas. And yes, there are more formulas you have to memorize. But if you do forget those formulas, we've already done two-dimensional shapes, right? And you have those area formulas that we've already done. If you can identify the individual pieces, you could find the area of each of those individual pieces to find the surface area as well. So on here, again, if you can identify what the correct net is, you can then find the area of each one of those shapes in order to get to our surface area. So again, coming up in the next section, there are several different ways that you can do surface area, all right? From a formula, are identifying all the separate shapes. All right, let's go through this real quick. So on number 2, which one of these is the correct net? B. All right, this one is B. All right, what about on 3? A. All right. On 4, what do you got? C. 5 is B. 6 is, what was it? C. And 7 is A. Good. So those are all the correct ones. Now again, going back to it real fast, just to talk a little bit about why. Again, number 2, made up of two triangles, and then the rest of the sides are squares. On number 3, we have one pentagon. The rest of the sides are triangles. Now, are your images, are your nets always going to be the exact same here? No. So they gave you an example of one that works. On a lot of these, there are multiples that work. So like the pentagonal pyramid, it doesn't matter where you put that pentagon, what you connect it to, right? Also, if you go down to like the square pyramid, you can do it the way they did it and open it from the vertex at the top, or just like the pentagonal one, you put the square on one of the triangles and connect all the triangles. So there's more than one net that works. All right. When it comes time for the FSA, if they have a net on there, there's a good chance there could be a multiple choice question with something like that. And you might have to then identify all the things that work. All right. Now, let's see. Cylinder, I didn't talk about that one. We had 2 circles. And then the side, if you think about the side as like a label on a can soup, you unroll it and it makes a rectangle. So that's the middle. We have down here on number 6, 2 hexagons. That's the only one with 2 hexagons. All the other sides are squares or rectangles. And then on number 7, we had our cube. Now, I did not give you another name for a cube yet, but cube is kind of special. A cube is a very specific name. There are other ways to name it. What else could you call number 7? Square. All right, it is a square. What though? So think about some of the other names that we've used. It is a square prism. So you can call this a square prism or rectangular prism. Cube is very specific. Cube actually makes this a specific type of shape. What is special about a cube? All the sides are equal. All right. So if all the sides are equal, go back to polygons. Now, I know we got to go back like 5 chapters here, but the first time we talked about polygons and we were naming polygons, there are special polygons that had all the sides the same. What do we call them? Okay, equilateral. You're right. So equilateral was just size. Equiangular was all angles. If it was equilateral and equiangular, it started with R. That one. Got the back of the waist. Regular. All right, a regular figure. Well, just like we have regular polygons, we have regular polyhedrons. A cube is a regular polyhedron. What that means is every single one of our faces is exactly the same. They are all congruent. All right. Okay. Last thing with this side, there are several shapes on here, and most of them fall into the category of polyhedrons. Can somebody refresh our memories? I haven't given you this word this year, but we have heard it in past math classes. What is a polyhedron? It's a two-dimensional solid that's made of what? Guesses? So the cube is a regular polyhedron, so that one's made up of congruent sides. So we already know the cube is a polyhedron, but some of these other shapes are also polyhedrons. They're just not regular. Guesses? No? All right. If I look at this board here, I will tell you 2, 3, 5, 6, and 7 are polyhedrons. 1 and 4 are not. No. So ask yourself this question: what's different about 1 and 4? All right, you have circles in there. So we have circular pieces in 1 and 4. So those two are not polyhedrons. All the other ones are only made up of, if you look at every single face, their faces are only polygons. Every single one of them is made up of only polygons. So a polyhedron is a three-dimensional figure made up of only polygons. All right. We'll use that term a little bit more later on. We need to talk next about cross sections. So anytime we have a three-dimensional figure, we can think about if we were to cut it or slice it with a two-dimensional plane, what shape would we end up with? So we're going to have other 2D shapes here. On here, we have a cube being sliced vertically down the middle. When you slice it vertically down the middle, you get a square. Now, there are other ways that you could slice this to get different shapes. So I want you to think about how you could slice it to form different shapes. Think about what shapes you can make and how you would have to cut it. Triangle. So I heard triangle, rectangle. All right. Now, one idea was cut it this way. One second, draw on here. Triangular prism. All right. So I want the two-dimensional shape that this is making. Now, first, the idea here was we thought maybe this might make a triangle. What shape is that actually going to make if I slice it that way? Can you see it? So look at it carefully. Look at the two-dimensional shape that I just drew. See it? See a triangle? Look at the black line I just drew. That's a rectangle, right? The black line is actually making a rectangle if you slice it that way. Now, I'm not saying you can't make a triangle. You definitely can. But slicing it through the middle, if I cut this in half, look at this black line. That's your rectangle, right? Now, on here, you could make a triangle, but it's not by slicing it through the middle. It's not even by slicing it vertically. You have to slice it diagonally at an angle. And I will bring this around so you can see it. You have to cut one of the corners off. Oh, you thought. There's a triangle. All right. I'll come around to the outside here in a second. rectangle, you have a triangle. But again, you can see it when it's sliced. All right. So again, when we have these shapes, we need to think about, if we're looking at a cross section, what shape is it going to make if that plane was to intersect with the other one? All right. So on here, there are lots of different shapes. There are lots of different shapes that you can make. All right. So for this first one, we had a square to start off. We had a rectangle. We have a triangle. That's about it. Now, are there going to be different shapes and sizes? Yeah, depending on where you cut it, there's lots of different ways you can cut it and make different shapes and sizes. Go down here to our pyramid. This is a, what type of pyramid again? What's our base? A pentagon. So a pentagonal pyramid. All right. On here, they showed a slice going horizontally through that shape. But what's true about that slice? What's that shape still? Still a pentagon. But are there other shapes that could be made? So think about other ways that we can slice it. What other shapes could we make by slicing it over? So take a minute to think about it. So I heard a couple of things already, but tell me, how would you slice it to get some of these shapes? So they already started off by giving you some idea in the actual question. I phrased my question a little bit different. First, it said, what's the shape that's shown? Yes, that is a pentagon. The second one asked if you were to slice it through the vertex at the top. What shape would that give? What was it? It's going to give you a triangle. So if you sliced it right through the vertex at the top, it's coming to a point, right? So the only 2D shape that you can get with that one going through that vertex is going to be a triangle. Now, there's lots of different triangles you can get, depending on what angle you slice it at. But there are other shapes that we can do if we cut it vertically. What did you say? Trapezoid. Right, I'm going to pass this around. I drew on there a couple different shapes. We can pass it around. But there are a triangle. There's a trapezoid, and there is a pentagon that I drew on there, based on slicing it 3 different ways. All right. So yeah, there are multiple ways that you can do this. What I want you to do now is think about these 3 shapes and what different things could you get by slicing them. So again, what other shapes could be formed by cross sections of these following shapes? All right, so take a couple minutes. Kind of hard to visualize, but the best you can, think about what you could make. So there is a special one for that one. I'll talk about it. That's not a shape that we covered. Oh, so that's square here. Where's the pyramid at so far? Semicircle on this one. Cylinder. It wouldn't quite look close, but it's a little bit off. All right. I'm passing around a couple other shapes. If you would just pass them around. So there are two on here that make some different shapes that you probably don't have names for, and that's okay. For the cone and the cylinder, you have rounded edges. All right. I will tell you that when you cut these shapes at an angle, you'll end up with some very special shapes that fall under a category of shapes called conics. All right. Things like parabolas, hyperbolas. We don't talk about those in geometry a lot. That's a little bit higher level. In Algebra 2, you do start to talk about those a little bit more. But if you see a curved shape, if you see like an oval shape, an ellipse, things like that, those are shapes that you'll get on your triangle and your cylinder that you will see in other classes later on. But there are lots of other two-dimensional shapes that we have talked about. So like in a cone, what are two main shapes that you can get when cutting a cone, either horizontally or vertically? A circle, all right. What else? Triangle. Those are two big ones. You should be able to recognize if you go through the top, you're going to get a triangle. If you go sideways, you're going to get a circle. Right. Square, for the square pyramid, what shapes could we get? Triangle. Rectangle. Anybody else? Trapezoids. Yeah. All right. So a lot of those same shapes that we saw in the first pyramid. All right. In the cylinder, what are we going to see? We're going to see circles. And no, not trapezoids on that one. You will see rectangles. Now, there is a common theme. All of these shapes that have bases. What happens if you cut horizontally, or I should say parallel to any of the bases? Well, so I'm talking about any of them. So let's go back for a second. It's going to be the same thing. All right, same thing as what? All right. So, oh, depends on the shape. I like that you said that. So when you have any one of these shapes, if you cut horizontally or parallel to one of your bases, your shape will be the same as whatever the base is. Same thing here, right? They showed this one being cut this way. It's the same as the base. On the cone that's being passed around, I cut it so that it was parallel to the base, and you'll see that there's a little circle at the top, right? Because the base is a circle. Anytime you cut any of these shapes parallel to a base, you will get the same shape as the base. Now, is it always the same size? No. So the size might change, but the shape will remain. All right, let's move on. Again, notice we keep going around. There's a lot to cover in these sections. All right. So the next thing we need to talk about is there is a pattern that we could find between all the faces, vertices, and edges on any polyhedron. So again, polyhedrons are the ones that are made up of polygons. So there's a special formula called Euler's formula. I know that's not what it looks like it spells. It looks like Euler, but it's actually pronounced Euler. And Euler's formula is how we can tell how many faces, vertices, and edges a shape has to have. So there are 4 images up here: a triangular prism, a rectangular prism, a pentagonal, and a hexagonal prism, all up here. I want you to go through this and find how many faces, vertices, and edges are in each one. And we'll do the first one together. So the triangular prism. How many faces are on our triangular prism?
4. No, 5.
5. Because we have 2 bases and then 3 rectangles as the sides for a total of 5. How many vertices? 6. So a vertice, again, those are our points here at the tips. So we have a total of 6. If we go on the first base, there's 3. We go on the other base, there's 3 more, for a total of 6. So we got, here, I'll mark them off as we go. 1, 2, 3, 4, 5, 6. All right. So our edges, an edge is where we have 2 of these faces come together. So this is an edge. Any one of those segments is considered an edge. So how many edges do we have? No, I heard somebody say it. 9. Thank you. 9. So there are 3 along each base. And then there's 3 along the sides for a total of 9. Now, at first glance, you look at this and it does not look like there's a pattern. Right? But fill the rest of these in, and I promise you there is a pattern between these values. So find how many faces, vertices, and edges you have in each one of these other shapes. So what'd you get for your faces on a rectangular prism? 6. All right, vertices and edges. 12. All right, the pentagonal. I got 7. So there's 5 around the sides, and then the 2 bases for a total of 7. All right. Then we had vertices. You said 10? Yeah, because you had 5 and 5 for the bases. The edges, 15. Now, there are patterns within these columns. Each time we went up by 1 for the type of prism that we had, right? This is 3 sides, this has 4 sides, 5 sides, 6 sides. And there's patterns here as well. Number of faces each time was increasing by what? Number of faces was increasing by 2? By 1. All right, so this one was 8. Number of vertices was increasing by 2 each time, so this was 12. And number of edges each time was increasing by 3. Now, There is a pattern though between the faces, vertices, and edges of each one. Does anybody see a pattern between each row of numbers? Oops, sorry. Yeah, what am I doing? 18, my bad. 18, added 3. I think I said 3 and wrote 3. But, all right. Does anybody think they see a pattern? There's a pattern between these numbers. I'll give you a hint. There's a missing number in order to figure this out. I'm going to throw this 2 over here and see if you guys can see it now. Is there anything that you see now? No? All right, so what we're seeing here, if we add those two, five plus 6 is 11, 9 plus 2 is 11. Those two add together is 14. Those two together is 14. 17. 17. 20. 20. This is our formula. So I gave you a spot on your paper to write the formula. This is the formula. F plus V equals E plus 2. F plus V equals E plus 2. The number of faces plus number of vertices is equal to the number of edges plus 2. And that equation will always hold true for our prism. Now, I'm going to leave this up there, but you have another question from the bottom. It's, does this hold true for the pyramids? So take a minute, look at the pyramids down there, identify faces, vertices, and edges, and see if it works for that formula as well. So take a couple minutes, find the faces, vertices, and edges. All right, so does it work for the pyramids? Want to start putting each one of those in yet? So the first pyramid that you have is a square pyramid. No, sorry, a triangular pyramid. You have a total of 4 faces, right? Okay, let's just go on to the slide. So we have number of faces is 4. Number of vertices. How many vertices do we have? We have 4. Number of edges. I have 4 as well, actually. Wait. 1, 2, 3, 4, 5, 6. Yeah, no, I'm wrong. 6. There we go. Six edges, 1, 2, 3, 4, 5, 6. So if we add this, does it equal that plus 2? Yes. All right. So in fact, Euler's rule, sometimes some people call it Euler's rule, some people call it Euler's law, but this formula that Euler invented does work for any polyhedron. So any of our shapes are made up of only polygons. This formula will hold true. So you have that other section there, the did you know how? That part, that's your little assignment. All right. But I do want you to take a picture of both sides and submit. I've got to make a spot for it on Canvas. Yeah, so I thought we were testing this period. It is sorry. I haven't made a spot for it on Canvas yet, so again, I will make one. Happy day. See you tomorrow.